Okay, we're going to pick up with example number 10. We are taking the derivative of the log of 5x minus x to the fourth base 3, all of that squared. So definitely chain rule going on here. Definitely want to use this formula also. So let's take the derivative. So the derivative of f would be f prime of x. Now you're going to do one layer at a time. So we are going to bring this 2 out in front. So this will be 2. Now recopy everything. Log base 3 of 5 minus x to the fourth power. And then if it makes you feel good, go ahead and put some parentheses around that and raise it to the first power, just so it's like, check, I did do that. And then times. Now you're going to take the derivative of the log part. So derivative of log is 1 over, and it's 1 over the argument, which in this case is 5 minus x to the fourth, times the natural log of the base. So the base for this is 3, so times the natural log of 3. Now we're going to multiply by the derivative of the inside. So the derivative of 5 minus x to the fourth is negative 4x to the third power. And that is your derivative for example number 10. I would not bother simplifying that unless it was a multiple choice question. Now, at the bottom, here's some tips that you can use for when you have like really ugly problems, like he says here. Make sure that you're simplifying early and often. The more simplified something is, the easier it is to work with, right? If you can use logarithms, now that you know how to take the derivative of a logarithm, I highly recommend using natural log. It's easier to work with than regular log. You don't have to worry about the different bases. Natural log base is always going to be e, and the easiest exponential to take a derivative of is e to the x. So I would stick with natural log and e. Also, if you have a function raised to a function, you can take the natural log of both sides. So that way this g of x would come out in front of your expression. So that would really be helpful as well. So let's see what we can do with example number 11. There's a couple of problems here, and they're pretty ugly, that's for sure. So I got all of this going on. I really don't feel like doing quotient rule and product rule. I'd rather kind of like make things a little easier. So what I'm going to do is take the natural log and then use properties of logarithms to help me simplify this into something easier to take the derivative. The one thing you have to remember, though, is that you need to do natural log of both sides of the equation, and you need to take the derivative of both sides of the equation. So if I want to use logarithms over here on the right, I need to use them on the left too. So I need to say natural log of y equals natural log of all of this. So e to the x times x squared plus 2, all of that to the fourth power. You got square root x plus 3, or I'm sorry, x plus 1 cubed under the square root, and then x squared plus 3 squared. Okay, so this is like one of the really good pre-calc logarithm questions that your pre-calculus teacher would be like, expand this or condense something like this. Not like you wouldn't condense this. This is condensed as far as it could go, but this would be a really good test question back in pre-calc to expand using properties of logarithms. In fact, I should give this one to Ms. Edwards. Anyway, here we go. So when you take the natural log of y is just natural log of y. When you take the natural log of this, you've got multiplication, you got an exponent going on here, you have division, more like a radical that needs to be turned into an exponent, all kinds of stuff. In fact, I think I am going to get rid of this radical right now and just write this as 3/2. So that way there's one little thing that is a little bit easier. So we're going to do natural log. Okay, so let's deal with the top. E to the x, this is multiplication, plus natural log of x squared plus 2 to the fourth power. Oh, wait a second, I have an exponent. I could take that 4 and let's put it in the front. Okay, now division minus. Now all of this is being divided. So when we do the subtraction, we got to put big brackets and put everything in here. okay? So this is going to be minus, now you're doing natural log down here too. So it's natural log of x plus 1 to the 3/2. Oh, there's that exponent that we could put out in the front. So let's see here if I can make this a little better. Put the 3/2 right there. Take it away from here. And then this is multiplication, so plus, and I am not going to have any space for the rest of my problem over here, I don't think. Let's see if I can squeeze this in. This will be natural log of x squared plus 3 squared, which would be 2 natural log of x squared plus 3. Okay? Just like that. And that's all in brackets. Now we're going to take the derivative. This was just using properties of logarithms, like we weren't actually doing a derivative here. Now we take the derivative. So the derivative of the natural log is 1 over y times dy over dx equals. Now, natural log of e cancels out. So that's just a x. The derivative of x is 1 dx over dx, but we're just going to write 1. Plus, now this 4 is a constant, so you just write the 4 down. The derivative of natural log is 1 over x squared plus 2 times the derivative of the argument, so times 2x. The derivative of 2 is just 0, so that goes away. Minus. All right, so this minus is going to go here, and it's going to go here. So I think I am just going to put the minus so I don't forget about it. And I'm going to carefully try to erase the brackets without erasing all of my other stuff. Okay, so this minus 3/2 is just a constant. The derivative of the natural log of x plus 1 is 1 over x plus 1. The derivative of x plus 1 is just 1. Minus 2 is just a constant. The derivative of the natural log of x squared plus 3 is 1 over x squared plus 3 times the derivative of x squared plus 3 is 2x. There you go. Now it's long, but I think it's a whole lot nicer than quotient rule, okay? I am not, if you haven't already figured it out, I am not a big fan of the quotient rule. I mean, I do it as a last resort. Okay, so what do we need to do here? We need to simplify maybe a little bit. We need to get the dy over dx by itself, so we could, let's see, dy over dx is going to equal 1 plus, let's see, this would be, I can do this, 8x over x squared plus 2 minus 3 over 2 times x plus 1 minus, let's see, this would be 2 times 2, so 4x over x squared plus 3. Now, we would have to take all of this and multiply it by y, because I had to get that y over on the other side of the equal sign, but I can't have y in my derivative for this one. Well, it doesn't really specify, so I suppose we could argue that we could have y. Another way that you could answer this would be to put in what y equals. Remember what y equals, it equals all this. So you could put e to the x squared plus 2 raised to the 4th power all over the square root of x plus 1 cubed times x squared plus 3 squared. And that would be your derivative, all in terms of x. So, and then I would leave it at that point, definitely. There you go. Okay, letter B. Now, this is an example of this thing up here, where you have 2 different functions. You have a function raised to a function. You cannot do the power rule with that. Power rule is only when you're raising a function to a number, like a plain old constant. This is a function raised to a function. So what you're going to do is you are going to set this equal to y, just call that y, because right now there's nothing there. So we need to call it something. So y equals, I'm going to rewrite it using the symmetric property, sine raised to the cosine x. So take the natural log of both sides. Natural log of y equals, now when you take the natural log over here, the cosine is going to come out in front. So it'll be cosine x natural log of sine x, like that. Okay, now we're ready to take the derivative. Take the derivative of the left-hand side. The natural log derivative is 1 over y, and then dy over dx. This is product rule, because these are two different things. That is not a constant. You have two different functions there. So this is u, and this is v. So you're going to take the derivative of u times by v plus the derivative of v times by u. So derivative of u is derivative of cosine is negative sine x times v, natural log of sine x, plus the derivative of v is 1 over, because it's natural log, so 1 over sine x times the derivative of sine x, which is cosine x, so we will just put that on top, times u, which is another cosine x. So remember, we still have to deal with this, get the dy over dx by itself. So let's see, this will be negative sine x, natural log of sine x, plus, let's see, cosine squared x over sine x, times y. Well, what was y? Y was sine of x raised to the cosine of x. So this would be times, so like all of that, times sine of x raised to cosine of x. And there's your derivative. Okay? Pretty cool stuff. Look at this stuff you guys are doing. You're in the big leagues now. All right, cool. One last example, and that is solving the derivative of x squared using logarithmic differentiation. So taking a log of both sides. So we all know that the derivative of x squared is just going to be 2x, but show how that can be done using logarithms. So you're going to take the natural log of both sides. So natural log of y equals the natural log of x squared. Okay? Now, take the derivative. Derivative of natural log of y is 1 over y times dy over dx. Natural log of x squared, take the derivative of that. So that's going to be 1 over x squared times the derivative. Well, actually, what could we have done with that way back at the beginning? Let's just back it up here a second. Take this 2 and put it right there. So this becomes 2 natural log of x. I'm trying to stay away from actually taking the derivative of x squared. And if I didn't rewrite that, I would have to. And that would kind of defeat the whole purpose of doing it this way. So use that property. So this would be 2 over the derivative of natural log of x, which is 1 over x. Okay? Like that. And then it would be like 1 over x dx over dx, which is just going to be 1. So now you need to get the dy over dx by itself. So this is going to become 2 times 1 over x is 2 over x times y. Well, we can't have y in our answer. Y is x squared. So substitute in x squared for y. Now simplify. 2x squared over x simplifies to 2x. And there you have it.